baud rate. Next topic. So far we have discussed about serial communication. If I'm going to transmit a serial data, we are going to decide the baud rate based on the frequency of the system. Now we are going to increase the baud rate. We are going to double the baud rate. How exactly we are going to do that? Here we'll discuss basic introduction to doubling of a baud rate. Here we have two different types of baud rate. We can increase baud rate by make use of two different ways. That is, first one is software, and second one is hardware. How exactly software? Okay, the first one is hardware. To use a higher frequency crystal, okay, the system crystal is to be changed. Okay, we cannot change frequently our crystal frequency of the system. For example, the system crystal frequency is 11.0592 for what we are going to use, that is IBM PC. If I need to increase the frequency of that, I cannot change the crystal. Why? Because that crystal frequency is not matched with the IBM PC what we are going to use for 8051. That is why it is not useful. We cannot do by hardware method. So that preferably we are going for hardware. If you want to go for hardware only, if I am going to change the crystal frequency, we are going to change with the PC. Equivalent of that, we are going to get the another configuration system. We are going to, in order to change the frequency, we are going to use some other frequency to map with respect to that. Okay, that is not possible. It is possible, but it is a cost wise everything it will be a disadvantage. So that we are going for software. Okay, we are going to make a double the baud rate by make use of a software. We are going to change a bit in the peak-on register. Okay, in the peak-on register, we are going to change one bit, and by make use of that software, we are going to change the, we are going to increase the baud rate. Okay, here option one is not feasible in many situations since the system is crystal is fixed. Why? Because in the 8051 what we are going to use IBM PC 11.0592 megahertz is fixed. That is why we cannot use that. Okay, it's a more important thing. Why? Because we are going to deal with the crystal frequency. That is why it's a important thing. So it is not feasible because the new crystal may not be compatible with the IBM PC or serial communication port baud rate. It will not be matched. That is why we are not going to use with the option one. That is, hardware is not satisfied to perform the doubling of a baud rate. We are going for second option, that is software method to change the bit in the peak-on register. Okay, there is a software way to double the baud rate of 8051 while the crystal frequency is fixed. This is done with the register called peak-on register. Peak-on register, as I showed here, this is your peak-on register. Here peak-on register is a 8-bit register. It's a peak-on means power control register. In the power peak-on register is an 8-bit register of 8 bits. Some of are not used. 1 minute. Okay, here the bit that is used for some of the pins are not used. This hyphen shows that these are not used. Okay, the serial communication is bit 7 D7 will be yes mode. Okay, that is serial mode bit. When the 8051 is powered up, we need to increase the baud rate. We are going to use with this mode, S mode. Okay, S mode of the peak-on register. Okay, if I am going to make it 0, it will be acting some other operation. If I'm going to make it is 1, it will be some other operation. Okay, that is the main difference between while I'm going to use 1 and while I'm going to use 0. Okay, if I'm going to use 0, you are going to increase. We are going to get some of the baud rate. If I'm going to use 1, it will be going to use some of the baud rates. That is the main difference. See, just example here. It is here move a comma pcon register. Place a copy of pcon in a accumulator. Now I am going to this pcon register, parallel control register. I am going to move it to the accumulator. It will be mapped with the 8-bit. Then set bit accumulator dot 7 means whatever the content in the pcon that I am going to copy it in the accumulator, means from 0 to 7, D0 to D7, the same it will be copied to accumulator. In set bit accumulator dot 7, whatever in the S mod it will be going to set. It means the D7 of S mod bit will be S mod is equal to 1. Why? Because it's a D7th bit. That is why it will be going to set means it's a 1. Now move put pcon comma a. If I'm going to copy accumulator, whatever the data here in the accumulator, that will be copied to your parallel counter, that is pcon register. It will be going to change the other bit, that is this bit it will be going to change. This is the simple example. Then we'll discuss in the next step if I'm going to take 0, how many what is the baud rate we are going to get. If I'm going to take 1, what is the baud rate I am going to get. That will be discussed in the next slide. Please make a note of this. Over. See here. Usually the same procedure, we are going to use external frequency, that is crystal frequency 11.0592 megahertz, that I am going to divide it by 12. Why? Because we have a 12 cycles. Okay, based on that we are going to get a some frequency we are going to get, that is 921.6 kilohertz what we are going to get usually. Now before what we are going to get, the baud rate we are going to get 9600, 4800, 2400, 1200. Okay, when S mod is equal to 0. Now here in the S mod is equal to 0. If I am going to make S mod is equal to 1, if I am going to make S mod is equal to 1, it will be doubling of a baud rate. Okay, before if I'm going to give 0 for -3 decimal hexa FD, I'm going to get a 9600. As we all know that how to get 9600, right? You know or not? ಗೊತ್ತೋ ಗೊತ್ತಿಲ್ವೋ ರೀ? Okay, machine cycle frequency 921.6 kilohertz we are going to get. If I'm going to divide it by 32, if I'm going to use S mod is equal to 0, this is my frequency 28,800 we are going to get. By make use of this, we are going to get these baud rates. If I'm going to divide it by 16 of this frequency, we'll get 57,600 hertz we are going to get. If I'm going to, based on this, I'm going to get these baud rates. Okay, make a note of this, then we'll discuss about the programs. When S mod is equal to 0, the 8051 will be divided with respect to 1 by 12 of the crystal frequency by 32, and it will be going to use the frequency of timer 1 to set the baud rate. In case of external frequency 11.0592, that is machine cycle frequency will be 11.0592 divided by 12, you will get 921.6, and further it will be going to divide it by 32, you will get the value of 28,800 for S mod 0. For 28,800, if I'm going to divide it by 3, you will get 9,600. 6, it will be 4,800. 12, it will be 2,400. If it is 24, it will be 1,200 you are going to get. For the baud rate for S mod is equal to 1. Okay, in the upper case, with the fixed crystal frequency, we can double the baud rate, by making of S mod is equal to 1. When the S mod is bit D7 of a P-con register will be set to 1. The 1/12 of the frequency, external frequency, is divided by 16 instead of 32. Okay, and then the frequency used by timer 1 to set the baud rate, it will be going to use external frequency 11.0592 megahertz divided by 12. It will be 921.6 kilohertz. If I'm going to divide that 16, we will get a 57.600 hertz. Since S mod is equal to 1. If I'm going to divide 57,600 by 3, you will get 19,300. Similarly, for 6, it will be 9,600. 12 for 4,800. For 24, it will be 2,400. If I'm going to compare with S mod 0 to S mod 1, obviously it will be double the baud rate. Like this, we are going to increase the baud rate. Any doubts? Any doubts?
No, sir.
Shall I move to next? Take this program. Assume that external frequency 11.0592 megahertz for the following program. State what this program does. Compute the frequency used by timer 1 to set the baud rate and find the baud rate of the data transfer. For the program, we need to find all these things. First one, this program transfer ASCII letter B 0100 0010 binary continuously it will be going to transfer. How you got to know? Here they had taken A comma hash B. Okay, we are going to transmit a letter B. ASCII letter B, equivalent of binary will be 0110 and 0010. 42 is the equivalent hexadecimal. 41 equivalent of ASCII A. 42 will be equivalent of B. Like that, we are going to decide the binary. with the external frequency 11.0592 megahertz. If it is a small one in the program, you need to calculate the baud rate. Okay, 11.0592. They are using -3. -3 they are going to use. It means that it's a 19,200 is the baud rate. For the timer 1, we are going to set. Second and third, it will be combination of both. Compute the frequency used by the timer 1. What is the frequency we are going to use by the timer 1? That is 57,600 Hertz. Or
2 minutes, sir.
okay. Trace the program. Solution is this one. This is the program. Trace the program. Serial communication program. What we discussed in the last class. The same procedure they had used. Labels they have used A_1, H_1. Whichever the label you want, you can use. No issues. Okay. Over?
Yes, sir.
Okay, take one simple problem. Simple problem. Find the baud rate. Find the baud rate. If TH1 is equal to -2, if TH1 is equal to -2, S mod is equal to 1, S mod is equal to 1, and crystal frequency Xtal is equal to 11.0592 megahertz, 11.0592 megahertz, full stop. Is this baud rate supported by IBM compatible PCs? Is this baud rate supported by IBM compatible PCs? Find the value and give the justification for the given problem. What is the baud rate you got?
28,829.
Okay, what is the justification?
Not compatible, sir.
Yes. Take one more problem. If the crystal frequency is 22 megahertz, if the crystal frequency is 22 megahertz, what will be the baud rate? What will be the baud rate if TH1 is equal to -3? If TH1 is equal to -3, and second one TH1 is equal to -12, TH1 is equal to -12, with S mod is equal to 0 and 1. 0 and 1. You have to find for both S mod is equal to 0 as well as S mod is equal to 1. For the frequency 22 megahertz, a TH value will be -3 and -12. Calculate. With S mod is equal to 0, we have a machine cycle frequency 22 by 12. That is 1833 kilohertz you will get. If it is divided by 32, 57 to 81. And TH1 will be -3, that is 3, 19,093. If it is divided by 12, it will be 4773. Then find for TH1 and TH1 -3 -12 for S mod is equal to 1. You can double this, so also 19093 for first case into 2 also you can do, or else 1833 kilohertz divided by 16, whatever the frequency you will get for that divided by 3 and 12, if you will do, you will get same answer. You check with both the ways. All of you turn on your camera. I'm going to check the answer one by one. Those who are turning on your camera, those showing the answer, for them I will give attendance. Others I will mark it as an absent. Make it fast. Got the answer?
Doing, sir.
Okay, Smaran and Akanksha. Fine, fine. What about others? Baud rate is not having any unit. You don't mention after finding the baud rate hertz. Don't mention that 19,200 like that. You have to mention. Okay, only 4. Akanksha Bharti, Layana, Smaran, Kavya, Jason Varghese, Harsha. 4 members. Chinmay, Dhanush. Okay. Chinmay. Okay. What about others? 6 members is enough attendance. Ahalya. See, very important topic, 6 marks. Definitely they will ask to find the baud rate. Chandan RV. S mod 0. 22 hertz, 22 megahertz. ಎಷ್ಟು ಬಂದಿದೆಯಾ 1833 divided by 16 ಮಾಡಿದ್ರೆ baud rate ಎಷ್ಟು What is the value of S mod for -3? 38 1 will get 38 186 baud rate. For TH to -12 9546. Check mark Chandan answer. Chandan, please check your answer.
Sir.
Please check your answer. If you take S mod is equal to 1, machine cycle frequency 22 divided by 12, 22 megahertz divided by 12, whatever the frequency you are going to get, that will be divided by 16. For that number, you have to divide it by -3 or +3. Only 8 members. Ajit, Akshita, Amutavalli, Ananya, Arif, Asha, Basaraj, Sivakrishna, Shrikari, Ashrita, Chaitanya, Chamala Rohit, Chetan K. Chetan is exit agutidane papa. Dikshit, Deepika, Deepti, Dhanushri, Vignesh Reddy, Krishna Rohit, Manish, Meghana, Girija, Hamsa, Harsha showed, I think. Kushala, now it's showing. Jitesh, no. Kirtana, Kubra, Kshiraj Prakash, Likit BR. Kushala is showing. Okay, fine. What about others? Out of 39, 9 members showed answer. Akshita is Harsha. Okay. Try this. Find the TH1 value in both decimal and hexa to set the baud rate to each of the following. First one will be 9600. Second one will be 4800. If S mod is equal to 1, assume external frequency, crystal frequency will be 11.0592. So far we are going to find the baud rate. Here they had given value, baud rate they had given. You have to find the TH1. Okay. Here 11.0592, S mod is equal to 1. We have the timer frequency 57600. If I'm going to divide it by this 57600 of whatever the baud rate they had given, you will get a 6. that will be, take it as a -6. Equivalent of 6 will be hexadecimal. FA you are going to get. Like this you are going to find. Make a note of this. So sometimes they are going to ask to find the baud rate. Sometimes they will give the baud rate. You are going to find for TH1 for both the hexadecimal as well as the decimal. Over. Got the solution, everyone? Any doubts? We will move to next. Take next one. Find the baud rate. If TH1 is equal to -2, S mod is equal to 1. This you already find, I think. You can, if you want, you can make a note of this. Okay, these are the standard baud rates. You can compare with these standard for your IBM PC. If the baud rate is not matched with these values, then you can write a comment. This baud rate is not supported by basic input output system of a PCs. However, the PC can be programmed to do data transfer at such a speed for hyperterminal in Windows support of other baud rates. make a note of this solution also and write on the comment what I had given here.